So from the examples that we've talked about so far, we see that brain is not imperative, but we do find it helpful, and we are actually kind of obsessed on the brain because being a social animal, we find behavior more important than its weight. So how much does behavior weigh? Well, nothing, right? You have the famous story about the division in NASA that had to calculate the weight of the rocket going to the moon, and they would go from the ones who made the rocket engines to the ones who made the lunar lander to the ones who wrote the software, and they would ask them how much every single bit of their equipment weighed, and at some point they got to the line item that was called software, and they asked the computer department, how much does the software weigh? And the head of the department says it weighs nothing at all. And they said, listen, even if it's just a fraction of a gram, we want to know how much it weighs. He said, well, it weighs nothing at all. And they just couldn't accept it. They said, look, we have to put something in the calculation. You can't put zero. And he said, wait, come and look. Do you see these rotating discs with the holes that carry the software? He said, yeah. He said, well, the software is the holes. So in the very same way, behavior is massless. Despite that being the case, we recognize the fact that behavior controls our plight, and we don't generally want our life to come to an end, and our plight is important to us. Therefore, behavior of others and ourselves is important to us in a way that is very disproportional to how much it weighs, because it doesn't weigh anything. That's probably the only example of one of the characteristics that we have, that there's no correlation between its weight and the importance with which we view it. Usually, when organs are larger, they weigh more, and when they weigh more, they can do more of the same. Usually. Longer legs can take you faster and farther. Longer necks can let you reach places that are higher. Longer trunk can reach further and get more food. In most cases, there's a correlation between the mass of an organ and the level of its utility. Not so with behavior. And behavior, as we mentioned earlier, is a part of the mind, which is an emergent property of the brain. But it does not seem to be the case that bigger brains yield more complex behaviors. Maybe they do, and we just don't recognize it, but if we look at the behavior of blue whales, sperm whales, elephants, animals with a markedly larger brain than humans.
Yeah, but isn't the brain proportional to the body which hosts it?
Most certainly not. Your body weighs much less than that of a rhinoceros, and your brain is bigger. Bigger in absolute terms, not just compared to the size of the body. So that's a resounding no. I think that it's conducive to entertain a visual analogy between the machinations of metabolics, the behavior of an organism, and the behavior of a hive. You've got this central intelligence that doesn't really move around much, just gives orders for the rest and orchestrates the entire system that is acting around it. In the case of DNA never leaves the nucleus. It's really good at not really reacting chemically with anything else. So there are a few specialized enzymes that unzip, zip back. Some make corrections, but by and large, DNA is not sensitive to the outside world, and it gives its orders by transcription into RNA, which leaves the nucleus and sends its message to the rest of the cell and the rest of the organism. The brain sits in the skull and transmits neural signals that the body carries out. The brain itself doesn't actually chew any food. It doesn't actually pound any dough. It doesn't actually pick any fruit. It just gives orders to do so.
Consumes energy, but...
It consumes energy, but it doesn't take action. The process of separating signals and creating thoughts is anti-entropic. When you organize your thoughts, you are fighting against the rule of entropy. According to the second law of thermodynamics, it's just the same heat, the same chemical makeup everywhere you go. If we give the second law of thermodynamics freedom to act until the end of time, we theoretically come to a universe that is totally boring in its uniformity. It's kind of like zero charge and zero matter with no concentrations anywhere. Let's go back to our metaphor. On the hive, if you disclude army ants, which are an exception, termite mound or an anthill will contain the orchestrator of action, which is the queen. Queens usually don't move. They usually can't. They're too big. They lay eggs, which give the hive a bridge into the future, and they give orders by the use of hormones and pheromones.
So they actually act as the brain of the hive.
The queen is the brain of the hive. Absolutely. And the brain is the queen of the body. And the DNA is the brain and the queen of the cell. I don't know what happens when army ants eat people, and they do sometimes. Do they save the brain for the queen? I don't know. Maybe they do. I'm not sure. I wouldn't be surprised. I think that Hannibal Lecter will tell you that the brain is the best part of a person. I've never asked him, though.